we have seen in thermal noise and Johnson noise that we will not measure noise in terms of direct noise power. We call it as RMS noise power because it is going to be average of all the noise power over a particular interval of time, because we cannot find the instantaneous value of noise at a particular given time. It is going to vary randomly, so we cannot rely upon the value of noise at a particular time. So this noise, the mathematical formula is given by the RMS noise power is going to be K by F power n into delta F. So K is a device parameter, so which will depend on whether you are going to use a MOSFET or whether you are going to use a transistor. So that value is given by the device, and F power n, n is going to be the exponent. So it is in the power, right? So usually the other name of a variable which is in the power is called as exponent, and n is almost close to unity. It will be 0.99 or it will be 1.01. Ideally, it is 1, but practically because of device characteristics, n value will be very much closer to 1. And delta F, obviously it is going to be the noise power bandwidth, the noise bandwidth of the device which you are going to measure, use it in the receiver side. So a question usually arises that what happens with this noise at DC? For a DC signal, whether it is a DC voltage or a DC current, the frequency is 0, right? So when you put F is equal to 0, mathematically, you will get infinite noise power. So actually, that is not the case, because infinity is a number which cannot be physically realizable. Theoretically, we will say as F tends to 0, you can say RMS noise tends to infinity, but practically the noise value will be very high, which cannot be computed or done by using numbers, because the power of noise will be such high at low frequency that it is not mathematically possible to compute that. And also all our receivers are going to work at a very high frequency range, right? So practically we don't have the purpose of evaluating this noise at DC. But one question may arise: what happens to this noise at DC? At DC, the theoretical value of noise is going to be infinity. Yes, that is from this equation. And I told you computing the average for flicker noise is going to be difficult, but if you take the frequency ratio, if you fix the interval and find the average value, it is going to be same. So that one property will help you in finding out the average value of noise in flicker noise. So finding the frequency range throughout the low frequency and high frequency will not give you a consistent average value. But if you fix the frequency range and find the mean square value, it will remain almost constant. If I measure from 100 kilohertz to 200 kilohertz, if I average out, I'll get one constant value. If I find from 200K to 300K, I'll get one constant value. These two constant values will be almost equal to each other. Okay, and flicker noise is predominantly present only in resistors. As we have seen in the case of thermal noise, only components dissipating power will produce noise. Ideal inductor will not produce noise. Ideal capacitor will not produce noise, but inductor having a resistance inside will produce noise. Capacitor having a resistance inside will produce noise. So same is applicable here also. Flicker noise is majority present in resistors, and sometimes it is called as excess noise, because resistors already have thermal noise and short noise, and this noise is also there as an additional quantity, so it is sometimes called as excess noise. So in a resistor, thermal noise will dominate. After thermal noise, short noise will dominate. After short noise, the flicker noise is going to dominate. So this flicker noise is also called as excess noise. So if you are going to have a resistance where a DC current is flowing, then the resistance exhibit maximum noise. So when there is DC current, only you have this 1 by F noise, and thermal noise, other things will not be there. They will be very minimal, because this noise power is going to be maximum. Because DC, the F is tending to 0, so noise power will be